Today, we will be dealing with the chemistry of benzenes. Along with the chemistry of benzenes, we'll be dealing with the electrophilic aromatic substitution. Now, there are many types of substitution that can occur to this benzene, but the one that we'll focus on today deals with bromination, which is adding a bromide to your aromatic ring. One of the steps is, without showing the whole entire mechanism, is this. You have your basic benzene. We're going to add Br2 to it. Now, without your catalyst FeBr3, the bromine would not be able to attach to our aromatic ring. So once this occurs, you take the bromine and you will see it placed at your one spot on the aromatic ring. So now your benzene ring has a bromide attached to it. This is just a basic way to see bromination. And don't forget that after one Br has been attached, the hydrogen bond that was displaced from it to reattach the bond down here ends up attaching to the bromide, and you get HBr as its byproduct. Now, bromination is just one way for electrophilic substitution on an aromatic ring. Another thing I want to say is this also works with other halides. You have Cl, you have bromide, you have iodide, and then you have, of course, F, fluoride. These will all work. And the only way that they will work with just a simple benzene ring on its own is if you have that catalyst, the Fe along with whatever substituent of halogen that is that you're adding, whether it be your Br3, Cl3, either or. And one other thing that I was going to point out along with this video is where they direct. And when I mean direct, I don't mean where it would be put onto the ring, because if it's the only substituent being added, of course it would be known to be put on carbon number 1. But once bromide or any of the halogens is added on, where would the second substituent go? So this is where we get into ortho, para, meta directing. Bromide, along with the other halogens, would only direct in two places, whether it be ortho or para. So when you have your bromide, chloride, iodide, fluoride in your one spot, and say you're adding HSO3 to the mix, it's not going to end up just being randomly placed on any of the other 5 carbons that are left open on the ring, but it will either direct in your ortho spot or your para spot. So here, if we had our bromide attached, we would end up having the HSO3 placed here or down here. And this also is with those other halogens. So in this video, you learned how bromination occurs with a benzene ring adding Br2 with your catalyst FeBr3, and how it could happen with any of the other halogens, Cl, iodide, or fluoride. And then also, if you have that substituent added onto your benzene ring first, then where would it direct a second substituent? And that would be in your ortho or your para directing. Thank you. And I hope you learned a little about electrophilic aromatic substitution. Okay, bye.